orange box. Yeah, instead of theta, we have what? We have, I mean, I could write it this way. This is I times 2 theta, right? And minus I times 2 theta. I could write it like that, you know? So just like theta is replaced with 2 theta. This is cosine 2 theta. Good grief, I've lost my half. This is supposed to be a quarter, right? So that's a half times a half. So I still have 1/2 left over. So I have 1 plus cosine of 2 theta. That cosine squared theta equals to 1/2 of 1 plus cosine 2 theta. This is an identity I pulled out of the thin air Friday to do this integration. So, you know, fun facts. Cosine squared theta is 1/2 1 plus cosine 2 theta. And sine squared theta is 1/2 of 1 minus the cosine of 2 theta. So you need to know these so-called half-angle formulas to deal with integrations of cosine squared and sine squared. It's like pretty much the only way to do it. What I just showed you is a kind of sneaky way to derive that identity. Now, I don't require you to know my secret trig, but I do require you to learn and to know and to be aware of these identities and know how to use them, right? And that's a somewhat innocuous demand on my part since I let you have a formula sheet, right? Example 2. So there's some problem in your homework which something like integrate cosine 3x times like sine of 2x. I think that's, or let's say 7x. There's some homework problem like that, right? How would you actually do such an integration? Well, I would point out with secret trig, you can derive the identity for this. There's an identity for this. All right, let me show you how. So cosine of 3x times the sine of 7x. So I use my boxed formulas over here. I convert that to 1/2 e to the 3ix minus, plus e to the minus 3ix. That's my cosine. And then I've got a 1/2i e to the 7ix minus e to the minus 7ix. I put the 1/4i out front just to keep it back out there for safekeeping. And, or I could write it as a half times 1/, I don't know, whatever, however you want to keep track of it. It's 2 times 2i if you like, I don't know, whatever. Doesn't matter. It's out there. So then let's just multiply. So what's e to the 3ix times e to the 7ix? We have e to the 10ix, right? And also this one, and that one gives me minus e to the what? Minus 3, minus 7, minus 10ix, right? And then, how about the other ones? This gives me 7 minus 3 is 4, right? So plus e to the 4ix. And then how about these two? Minus e to the minus 4ix. I'll write one more step just to make it really, really more obvious. This is 1/2 of 1/2i e to the 10ix minus e to the minus 10ix plus 1/2 e to the 4ix minus e to the minus 4ix. Go back to the boxed formulas again, right? This time we've got a 1/2i factor, and we've got, a difference of imaginary exponentials. These are signs. So this is the sine of 10x, and this is the sine of 4x. So we have 1/2 sine of 10x plus 1/2 sine of 4x. Why do we care? Why do you care about this? Well, can you integrate cosine 3x times sine 7x? I can't. Can we integrate this? All right, so we have, I'll do it up here. So we have the integral of 1/2 sine of 10x. How can I do these kinds of integrations? This is I can use a u substitution, right? Actually, 2 u substitutions. Right? I'll break it up into 2 pieces. So I have 1/2 integral of the sine of 10x dx plus 1/2 integral of sine of 4x. For this one, I suggest we make that u equal to 10x, right? So du is 10 dx, right? Or dx is 1/10 du. And whenever I've got like 2 different u substitutions I'm thinking about, I'll use a different letter for the other u substitution. Sometimes I like use u1 and u2, but you could also just use a different letter, like w equals to 4x, right? So then dw is 4 dx. In other words, dx is 1/4 dw. So with these 2 substitutions in mind, we have 1/20th, right? 1/20th the integral of the sine of u du plus 1/8 the integral of the sine of w dw. I've just factored out the 10th and the 4th that come from changing the dx to du or the dx to dw respectively. So what's the integral sign? Minus cosine, but yes, minus 1/20th cosine of u minus 1/8 cosine of w plus a constant. Now we have to undo our substitutions. Minus 1/20th cosine of 10x minus 1/8 cosine of 4x plus a constant, and there you go. Now the hard part here, of course, is knowing about this trig identity, right? Now, you guys can put the trig identity, let's generalize this. What would happen if instead of having 3 and 7, what if I had like cosine of ax times the sine of bx? What would happen? We get what? 1/2 sine of something times x plus 1/2 sine of something times x. Tell me what the something and the something are. How are they related to a and b? How how did we get this 10 and this 4? 10 was a plus b, right? 3 plus 7. So we're going to have like a plus b on the one sign. And what is it? It's 7 minus 3, right? So it's b minus a on the other term. And so, like, I mean, if I were you, this is one of the formulas I would put on my formula sheet, because I know if I know this trig identity, then I can integrate products of cosine and sine. Right? Without the trig identity, I'm really up a creek. Now, there are similar identities for, like, the product of cosine with cosine, and also, sine with sine. But I don't have enough time to even write those on the board at the moment, so I won't do that. But anyway, this is the start of a conversation. I probably have another 20, 30 minutes of sharing with you how to do integrals of sines and cosines and stuff. Like, we should talk about how to do, like, integral of, sine cubed. Or we should talk about how to do integral of, cosine cubed and powers of tangent and stuff like that. There's a bunch of common tricks I should share with you. But anyway, Wednesday we'll just be doing more and more U substitution and trig integrals. So, and we have time for your homework questions, of course. So anyway, and if you haven't given me the last mission already, please give it to me.